In this video, we will talk about arc length, areas of sectors, and linear and angular speed. We also call it velocity. So this section is a little challenging for many students. So from all the times that I taught trig, a lot of students tend to be very freaked out about this section because there's a lot of word problems. So just the only thing that I would just say is keep in mind the keywords, like what is some of the keywords, and that will kind of help you with the formula. So here let's start off with the length of an arc. So the length of an arc is given by the formula S equals R theta. So here S, it stands for the arc length. So how like the length of this particular arc. So how we're just looking at this thing. So if we put a string here, how long is this guy? R is just the radius, theta is just the angle in radians. So if I know what theta is, if I know what R is, I can figure out the length of this particular arc. Okay. So let's just jump in with the formula. I'm sorry, with an example. Another way that you can kind of think about this also is that you can always solve for theta. Sometimes you might have to solve for theta. So you have to be very good with solving these equations as well. So because it's not just going to be a plug-in and then you get the answer. So let's start off with the first one. So a 15-inch long pendulum swings through an angle of pi over 9 radians. So find the length of the arc through which it swings. So if you think about a pendulum, let me write it over here. So if you have a pendulum like this, well, it's just going to be swinging. And remember that it can swing maybe a whole bunch of a whole entire circle if you have a pendulum. I mean, that's not really what a pendulum does, but it can swing like that. Okay, so think about if it's 15 inches long, well, you can think about that as a radius. So this is 15 inches long. Okay, and it's swinging through an angle of pi over 9 radians. Okay, so this angle that it swings by, so if it swings left to right or whatever, it's going to be pi over 9. Okay, doesn't really matter where it's swinging. Okay, so find the length of the arc through which it swings. So I want to know this length S. Okay, so this is a really plug and check problems because you have S is equal to R theta. Because S is just the arc length, R is the radius, theta is just the angle. So R in this case is going to be 15. Theta is going to be pi over 9. Okay, so let's put this in our calculator. So 15 pi over 9, that's just going to give me 5 pi over 3. Okay, now in this case, the length is going to be measured in inches, so this is just in inches. This is what we call the exact answer, because it's closed form. It's not given to you as a decimal. If I were to put this as a decimal and put this in my calculator, I would have gotten 5.24. This guy is what we call my approximate answer. Okay, so be aware, if I don't say round to these decimal places, what I really want is your exact answer. So I want the exact answer. If I tell you round to these amount of decimal places, then I want the approximate answer. Okay? Okay, I'll try to be a little good about that. I'm not really good. At exams, I'm good, but sometimes when I do some classwork, I'm really terrible at that. But for right now, let's just say we want either the some exact answers. Or if I say it in the problem, I'm like, oh, let's round here. Okay. All right. So here's another problem. So find the length of the arc of a circle of radius 5 inches, suspended by a central angle of 320 degrees. Okay, so here is my circle. It has radius 5. Okay, so from the center to a point, it's going to be radius 5 inches. And I am looking at a central angle, so the angle is going to be 220 degrees. So maybe, so if this is 180, then it'll be around here. Okay, so this whole thing, this whole angle is going to be 220 degrees. And we're looking for this arc length. We're looking for all of this length. Okay, so a couple things. We know that we have to find the arc length, so we know that the formula is going to be S equals R theta. The only thing is that remember that theta here, if we go back, theta has to be in radians. So we have to convert this 220 into radians. So 220 degrees, let's convert this into radians. So we know that we have 180 degrees on the bottom, pi radians on the top. So I'm going to put 220 degrees divided by 180. And what I'm going to get is 11 pi over 9. Okay, so this is going to be how many radians I'm going through. So now I'm going to plug it into the formula, S equals R theta. So S, I'm trying to figure out, R is going to be equal to 5, and then 11 pi over 9. Okay, so this is going to give me 55 pi over 9. Okay, and in this case, this is in inches. Okay, so that's the length of that particular arc. Okay, and now let's go to the next one. So the distance along the surface of the Earth between New York City and Paris is 3,600 miles. If the Earth's radius is 4,000 miles, find the central angle. Okay, so you have to be very careful here because we have a couple of things. So we do know the radius. Okay, so we know what the radius is. So the radius is equal to 4,000 miles. We know that along the surface between New York City and Paris, this is going to be 3,600 miles. So if I were to kind of draw, and I remember I can't draw, so let's say this is a circle. Okay, we know that this is the Earth, and we know that this is the center. And we know that the radius is 4,000 miles. And let's say New York City's right here. And Paris maybe could be over here. Then the length, the arc length of this guy is going to be 3,600. Okay, so this guy right here is 3,600. And we know what the radius is. We want to figure out what this angle theta is going to be. Okay, so we know that S is equal to R theta. So the distance on the surface is going to be 3,600. That is my S. The radius is 4,000. And then theta is what we're trying to figure out. So we need to figure out what theta is. So I'm going to divide by 4,000. Divide by 4,000. So now here theta, which is going to be in radians already, is going to be 3,600 divided by 4,000. That's going to give me 0.9 radians. Okay. Okay, so that's going to be the answer for that one. Okay, so that's just arc length. Okay, so now let's look at the area of a sector. Okay, so the area of a sector is basically using angles to find areas. So a sector, if you think about it, is just going to be a region of a circle bounded by 2 radii and intercepted by the arc. So here is a good example of a circle. So think about this as like a slice of pizza, and you're trying to figure out how much of that slice or the area of this entire slice. So when you think about area, we're thinking about everything that's in the inside, okay? So one way that we can do it is using this particular formula. Area is equal to 1/2 theta r squared. So this formula was derived from the formula for the area of a circle. So area equals pi r squared. So using this area formula, you can try to figure out the area of a sector. Okay, so let's just do a couple of examples. So just using this formula. So an automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. So what is the area of the sector of grass a sprinkler waters? So round to 2 decimal places. Okay. So one more thing. Theta here should also be in radians. Okay, not in degrees. Just FYI. Okay, so let's do this problem now. So here, just a super easy problem because all you want to just figure out is just the area. Now, the only thing that you have to be careful with is this 30 degrees. We do not want this 30 degrees. So let's convert it. So 30 degrees, whoops, not 36. 30 degrees. So you have 180 degrees on the bottom and then pi radians on the top. Okay, so you're going to have 30 degrees, so 30 pi over 180, that's going to give me pi over 6 radians. Okay, so let's see how much of this, how much area is the sprinkler really spraying. So, so you have area is equal to 1/2 theta r squared. Okay, so you have 1/2 theta in this case is going to be pi over 6. Okay, r is going to be, in this case, is going to be this 20. Okay, and then I'm going to square this. Okay, now notice here that the answer wants it in 2 decimal places, which means I do want the approximate answer. Okay, so that these little funky looking lines just mean approximately. So we're going to have 1 over 2, and then times pi over 6. And then you're going to have 20 squared. Okay, so what I'm going to have is 104.72. And because this is area, we're going to look at the units, which is going to be feet. So we're going to write feet and then squared. Okay, so that's basically the unit of area because it's 2-dimensional. Okay, whereas distance is just 1-dimensional. So 104.72 feet squared is basically our answer. Okay. Alrighty, so there really is not much to areas of sectors. It's pretty self-explanatory. But now what we're gonna do, whoops, what happens? Okay, so now what we're gonna do is do linear and angular speed. Okay, and actually let me go ahead and do that in a different video because this one can be a little bit, I think we need a little bit more time for this one.